Good morning, Brussels. Well, thanks for that. And indeed, my name is Mikko Hypponen, and we'll be starting this year's BruCON off by going through memories. Memories of what exactly we've gone through. If we think about how much things have changed from the early days of virus attacks, the first early on hackers, the first defacements, the first spam runs, the first Trojans, all the way to where we are today, we have actually gone through a lot. And we will be going through here in BruCON what's happening right now. So I want to give some background to start, and I believe I should be able to give you some sort of a run-through because I've been doing this for quite a while myself. The very first computer virus for PCs was found in 1986. It was called Brain. I have it with me, right here. This is Brain. I actually went through our old cupboards at the lab at F-Secure and I found it. We have a box full of floppies which basically has the first 100 viruses in history, or the first 100 PC viruses. Let me emphasize, PC viruses. Yes, there were some earlier cases for some mainframe systems, some Apple II worms before this, and I really start counting from this because of course this is a PC virus and we are still fighting PC viruses today. They are a major problem right now. Right now, 24 years later. Now, Brain was written in Pakistan. I actually wasn't working in the field at the time because nobody was working in the field at the time. There was no PC security industry. There was no antivirus industry. There was only one virus, right? I joined a little bit later, around 1990, 1991. But I have seen this problem explode from these very early days to where we are today. And I've seen the security industry explode from those early startups to where we are today, in the multi-billion-dollar industry that is the security industry. When I joined F-Secure, I was employee number 6. There were 6 of us looking at these things and trying to figure out whether there would be actually something that we could do to stop all these viruses and things like that. But of course, things changed. Now we have 850 people in 22 countries doing basically the same thing. And companies like Symantec and McAfee, well, of course today Intel, have thousands of people doing exactly the same thing. So what actually happened during these 24 years? Brain is going to be 25 next year. I'm wondering if we should throw a birthday party or what. So let's go through what exactly happened. Let's start from Brain, which actually is very interesting if you take a closer look into it. Brain spreads through floppies. Of course, Brain cannot be a problem anymore because nobody uses floppies. Of course, nobody has been using them for quite a while. But there are interesting things in there. For example, if you compare to how worms spread today. Of course, today they spread over the web, they spread over email, which means they spread over the net, which means geography isn't involved. Malware can jump from one computer in Brussels to one computer in Sydney in milliseconds at the speed of light. When viruses were spreading on floppies, of course, they weren't spreading at the speed of light. They were spreading at the speed of travel. If you wanted to infect a computer in Sydney and you were in Brussels, you had to fly to Sydney and bring the virus with you on the floppy. That's the only way it would spread. There's no other way for these things to spread. So it seems a bit funny that these could have been a problem at all. Yet, they were a huge problem. Many of these early floppy-based viruses, both for 5¼ inch floppies and 3½ inch floppies, were huge global outbreaks. We saw, for example, the 4 virus infect research stations, both at the North Pole and the South Pole, which pretty much tells you that they really went everywhere. And we have a very close equivalent today. The equivalent is this, USB stick. USB sticks and USB words are a major problem today. Of course, they spread at the speed of travel as well. Many of these only spread over USB sticks, which means if you want to move one of these from Brussels to Sydney, you have to fly from Brussels to Sydney. Another interesting thing about Brain. Brain was a rootkit, for real. At the time, we didn't call them rootkits, we called them stealth viruses. But basically what Brain did is that it infected boot sectors. It wrote itself on the first sector of the floppies. And of course, at the time in 1986, nobody had hard drives, only floppies. You had a computer with no hard drive, just 2 floppy drives, that would be the norm. So it would write itself the first 512 bytes on your floppy disk. And once your machine was infected, if you tried reading that first sector, brain would be in memory and it would have intercepted the interrupt to read sectors, and it would actually redirect all the read attempts to sector number 1 to the last sector of the floppy where it had stored the original input. Well, that is a rootkit. That's exactly what rootkits do. They hide themselves. If you try to look at the thing rootkit is trying to hide, it hides it for you. So it's actually pretty amazing how advanced the very first PC virus was. So what did it do? Nothing. It just spread. Like most of the early viruses, they were just spreading. They tried to do nothing at all. Now we saw copycat of the copycat like Stoned, then we had viruses like Cascade, which actually was no longer spreading on floppy disk boot sectors. This was actually a parasitic infector which would infect your own programs, like your games. And when you were swapping them between PCs, you would also swap the virus. Yankee Doodle, very similar. This was found in 1989, 3 years after Brain. Dark Avenger from Bulgaria. We actually spent quite a while at the time trying to figure out who is Dark Avenger. There were many theories about the guy himself, but he was never found. Form, which I already mentioned, probably the most widespread boot sector virus in history. And then in 1991, Omega. And I can tell you that Omega is not important to anyone else in this room except me. And it's important to me because this was the first virus I ever analyzed in my life. So I had a background history in programming, especially assembly level programming. When I started working at F-Secure, we got the first virus sample sent to us from a customer. Our CEO passed it to me because I knew assembly, so basically I could take it apart and figure out what it does. And I did that. I printed out the code on a stack of papers, went through it with Ralph Brown's interrupt lists, trying to figure out what exactly this program was trying to do. Actually, our operation at the time was so small, I didn't even have a spare computer I could infect to see what it does. We couldn't afford that. So I actually just went through the code trying to figure out what it does. And I found this feature in there which would activate a subroutine on a certain date. And the date check whether it's a Friday and whether it's the 13th of the month. So every time it's Friday the 13th, it would do something. And what it did is that it would actually, well, I tried figuring out in the code, it would actually display one character on screen. And I looked at the ASCII chart and to me it looked like it's the Omega character. So I named the virus Omega. And the name stuck. If you actually go Googling around for the Omega virus, you'll still find this virus in different virus description databases. It was the first virus I ever named. Then, maybe 2 months later, I actually got my first replicant machine, the first machine I could actually infect with viruses and see what they do. So I infected it with Omega, and I changed the date to Friday the 13th, and I ran the virus. And yes, it displayed the Omega character, so I got it right. I was so proud. And later on, we started a tradition at F-Secure, which is that every time somebody's been 10 years with the company, you get an Omega watch like this. So I should have named the virus Ferrari. Interestingly enough, in a couple of months, it's going to be 20 years for me at F-Secure. And I'm the first one to break that, so I'll see, maybe I'll get another watch, I don't know yet. We'll see. Then we started seeing viruses which were destructive. Those of you who were around following the media in 1992 might remember the Michelangelo media crisis or media hype. This was all over the mainstream press. This virus was activating on the 26th of March and it would overwrite hard drives. Why? Nobody knows. This was very typical at the time. Many of the early virus writers wanted to cause chaos, wanted to cause destruction, which is something we actually don't see anymore. But at the early times, it was pretty normal to find a virus which would overwrite the hard drive. And everybody was waiting for some massive catastrophe to happen on the 26th of March, and then 26th of March happened, and there was only a handful of computers lost around the world. And of course, we've seen the same phenomenon over and over again. Remember Y2K? Everybody was expecting something huge to happen, but because of all the attention, all the problems were fixed before Y2K actually happened. Pretty much the same thing happened here. We've seen it over and over again. We saw it with Configure, for example. And then we started seeing more and more viruses which would start to play tricks with the user, which were actually visual. A couple of code snippets here that I'm trying to run for real. And this is always fun because what I'm actually going to do now, I'm going to run code snippets, DOS code snippets from 1992 or 3, which are going to change the display to a really funky refresh rate. So we'll see if these projectors can handle it. I'm going to run a piece of virus. Of course, I've actually removed the malicious parts. Actually, I'm running a COM file. You see that? That's my Windows computer, this computer right here, while I'm about to run a COM file. How often do you actually run COM files? But it actually works. You can do this in Windows even today. Let's see if the projector can handle it. Yes, you see that? That's a piece of code from 1992. And that's a piece of code I extracted myself from the B-sign virus. And this is what the B-sign virus does. When you boot up your computer, every 25th boot or every 30th boot, it won't boot up. Instead, it has this V animation on your screen, and then it crashes the computer. So it's like announces itself to the owner of the computer, which again is something we don't see today. Today's viruses don't announce themselves at all. They don't play music, they don't have animations. Today you don't know if you're infected. But back then, virus writers were playing games with the users. Here's another one. Elvira virus, written in France by a virus writer called Spansta. That works as well. I like your projector, very nice. That's a poem, talks about a French girl called Elvira, something like that. Again, shows it randomly to the user. Very nice effect. And of course, this is like 120 bytes, so very tight coding as it would be at the time. Another example, this is the Walker virus. Guess why it's called the Walker? Every now and then you would have a guy walk across your screen. So you would know you're infected because there's a guy walking across your screen. You want to see more of these? I can show you more of these. Then Zook would show this on your screen when you boot up. They would continue booting up. Joshi, on the birthday of the virus writer himself, when you boot up the computer on the birthday, you won't boot up. It will actually show this to you and it won't continue booting until you type happy birthday, Joshi. Then it will boot up. So again, playing game. And maybe one more example from Spanska. This guy actually had some fairly nice routines in his viruses. Let's see if this one works. This is a really neat refresh rate, as you can see. But small demo effect. Again, this is 1993. And my last example is the casino virus, which actually works so that when it activates on random dates, it takes a copy of your file allocation table, the FAT, the FAT system at the time in DOS systems had the allocation table at the beginning of the hard drive right after boot sectors. So you would take a copy of that to RAM, then it would overwrite the FAT on your drive. Then it would display this screen where it explains, I've just overwritten your FAT, you've just lost all your files. But I have a copy in memory, and now you can play the game of chatbot. You have 5 tries. If you get the chatbot, it will write the FAT back to your drive, and you get your files back. You can win your files back, and it actually does this. If you win, it actually will give you your files back. If you lose, you lose. If you reboot, you lose, because the FAT has already been overwritten. There's a copy in RAM. That's what, and we can actually play this for real. We can actually even win this for real. Of course, here, the one I'm running right now has not done anything to my drive, but it is the original code, so let's play. Well, if I get 3 pound signs right next to each other here in the center, I can win. But I didn't. You asshole, you've lost, say by your balls. And then it crashes the computer, which means you can't recover your FAT from RAM. So, but I think I've made my point about how different they were at the time. Then we started seeing virus-generated toolkits like NTE and VCL. And VCL was actually fairly nice. It had a graphical user interface where you would select options of what kind of virus you would want to create, and it would create the virus for you. And this, we thought at the time, is a catastrophe. We can't keep up with all the viruses they can make with these, which of course wasn't true. We could fairly simply create a generic description which would detect every single virus you can create with a toolkit like this. And then we started seeing Windows viruses, where, again, in the early 90s, WinVir was the very first virus running under 16-bit Windows, Windows 3.0 at the time. We actually found this ourselves. I remember this was how we started making connections within the antivirus industry, because we found this and we put out a warning on it, and it was picked up by the media and all that, and we started getting calls from IBM in USA and McAfee and all the others, and started building the connections, which many of those connections we still have today. The antivirus industry is actually a very close community. There aren't that many top-level researchers in the world, and they've been around for a while, and they just typically change from one company to another. Pretty much everybody knows everyone else. There's surprisingly large amounts of cooperation within diverse competitors among the antivirus industry, which is really great. Then we had others like Monkey, OneHalf. OneHalf is really interesting because this one, written in Slovakia, what it does is that it starts slowly encrypting your hard drive. From the beginning of your drive to the end, it slowly encrypts every single sector you have. But it's full stealth, meaning that as long as the virus is in memory, it decrypts it on the fly. So it's like on-the-fly encryption. You don't know that your hard drive is encrypted. Everything works fine. But if you remove the virus, then the virus isn't there anymore to decrypt the hard drive for you. So then you lose you're fine as long as you don't remove the virus. And it stores the decryption key within the virus code itself. So if you just overwrite the virus, you lose, and there's no way to recover your files. Very interesting. Again, no reason to do this. The guy wasn't really getting anything out of this. He was just, I guess, funny at the time. This was in 1994. And then we entered the stage of macroviruses. Concept did not infect DOS, it did not infect Windows, it infected Word. So Word, at the time, with Word 95, had support for macros. Basically, you have a document file which would run a VBA, Visual Basic for Application, script when you open up the document. Well, guess what? Of course, somebody wrote a virus which would infect your doc file, and when you gave that doc file to someone else and they opened it, it would infect all the other doc files he had. And when he gives some of those to someone else, it continues spreading. And these became very, very big problem very, very quickly. They became the biggest problem we had for 2 to 3 years. We only got rid of macroviruses when Office 97 came out and Microsoft broke the VBA macro language. They broke backwards compatibility on purpose to get rid of the problem. Now we got rid of the problem. So that's actually a good example of how you can get rid of viruses when you change their environment. LaRue was a similar virus. This one was infecting Excel files. And LaRue was nasty because it would do data labeling. It would modify the contents of your sheets. So when you're working with numbers in Excel, it would do small errors. Change just a tiny amount, just a small change there. Just add 1% in that number. Deduct 1% from that number. Which means you don't notice that your numbers are wrong. And you keep using the wrong data. And you keep backing up the wrong data. And then when you realize your data is wrong, you realize it's been wrong for months, and you realize that all your backups are wrong as well. And you don't know when it started, you don't know which is modified and which is not. Very nasty cases. BOSA, a Windows binary virus at the time, which would display a message. This is the equivalent of what we used to see in the DOS days, except this was a Windows virus showing a Windows prompt like this, naming the gang behind it or their nicknames. This was an Australian virus running gang. And we started to see more and more of these gang, like underground groups, running viruses for fame, competing with other underground groups. Again, there was no money involved. These guys were just doing it for fame. And they were really active in putting out their own magazines and putting out lots of viruses, trying to be the first gang to write the first Windows virus, the first 32-bit virus, the first virus for HP 48 calculators, whatever. Try to break new ground. Multiple virus, which you would know you're infected because your Windows would look like this. And then we saw Remote Explorer, which was the first backdoor inside a virus we ever saw, so it gave backdoor access to your infected Windows box. Happy99, this is the first email. It's called Happy99 because it told you Happy New Year 1999. It was spreading so in 1998 and early 1999. And this is the first email outbreak ever. We entered the email worm era and we stayed in the email worm era from here all the way until, well, 2000 something. The email worms are no longer the major problem, but they were the biggest problem for a number of years, for at least 7 years. And there were so many different email worms at the time spreading around, but the best known was probably this one, Melissa, which was actually a combination of a Word macrovirus and an email worm. So it would take one of your own document files, infect the document file, and email it to people listed in your address book. So not only you would infect your friends, but you would actually lose one of your files. It would take one of your own files, a love letter, or whatever, company secrets or patent applications, something that you've created yourself. Infect that file and mail it to random people in the random. Now, why email worms were so successful? Because there's an element of trust in email. If my machine gets infected, email worms would send themselves to everybody listed in my address book. And people listed in my address book know me. They know who I am. They trust me, at least some of them trust me, right? So, for example, I would send an infected email to my brother. And my brother gets an email from me and he's like, okay, Mikko sent something. What's this? There's an attachment. I'm going to open up the attachment. It's probably something funny because Mikko sent it. And if Mikko didn't send it, Mikko's machine is infected. So this trust really helped email worms to go around. So how did we get rid of email worms? Well, we changed the environment. Today, if I would try to send an exe attachment via email to all of you, I'm guessing nobody would get it. Security systems on my computer, at the operator, at the ISP, at your firewall, at your email gateways, at your computer, something would strip away the executable because that's scary and that's dangerous. So it doesn't work anymore. We got rid of email worms because the filtering got so aggressive. The email worms we only see today are like the Here You Have outbreak we saw 2 weeks ago, which had no attachment. It was emailing out links. And that link pointed out to a binary. So attachment-based attacks don't really work anymore at all. And this element of trust that enabled email worms to spread 10 years ago actually is still very relevant today, but in another environment. And that environment is Facebook. Facebook and other social networks. Because these social networks are all about social connections. Basically, they are about trust. You build your real-world contacts in this online environment. So you have there your friends, your family, your colleagues, and you trust these people. And this is the reason why we today see Facebook accounts being phished and stolen. When people see Facebook phishing, they're typically very confused. And why is somebody phishing for Facebook accounts? They can understand if there's a phishing attack against a bank or a phishing attack against a credit card company because there's money involved, right? But why is somebody phishing for Facebook accounts? Because there's no money to be made with stolen Facebook accounts. Except that's incorrect. There is money to be made with Facebook accounts. It's all about misusing the trust. So, if my Facebook account is stolen, which is actually very hard to do because I don't have a Facebook account, but let's say I would, and it would be stolen, the reason why they would steal it and what they would do with the account is that they would send emails to my contacts, or not emails, but Facebook messages or wall posts. Hi everybody, check out this cool link. And my brother would see that message, thinks it's coming from me because it looks like it's coming from me. Oh, that's probably something funny, I'm going to click on that link. And the link goes outside of Facebook to some website which has an exploit which takes over my brother's computer and misuses the computer to make money. So the trust element is still very much relevant. No longer in email, now on the web, especially the social web. Melissa was very famous, but so was Love Letter. In fact, when Melissa was still running around, we were really interested in the background of the name. There was this story that Melissa was named after a stripper from Las Vegas. And at the time, I tried to get budget to go and research that. I never could make it go through. So. But then we found Love Letter, which was a year later. And both of these were massive cases at the time, very large outbreaks, very big media cases as well. These were all over the news because they were so large. Many people still remember these. In fact, many people still today, when the people who aren't actually working in this field, normal people on the streets, they remember Melissa, they remember Love Letter, they remember Blaster and Slammer, these huge cases, and they don't see these cases anymore. We don't have these huge outbreaks anymore. So people tend to think that the situation used to be really bad 10 years ago, now it's pretty good because there's nothing in the news. And of course that's incorrect. The outbreaks, yes, they have disappeared, but they haven't disappeared because the situation would have been getting better. They disappeared because the enemy has changed. So Love Letter made the front page of CNN at the time. In fact, here's my quote from CNN in 1999. New computer virus not expected to become widespread. And it became the most widespread virus ever at the time. So there you go. I'm not always correct, unfortunately. And then we found Anna Kournikova. This was one of the viruses which I remember because I got a phone call from a customer who was running our product. And he had heard about the Anna Kournikova virus from the radio in the morning on his way to work. So there's this outbreak, email world outbreak going around, called Anna Kournikova because it claims to contain Anna Kournikova images. And Anna Kournikova is this tennis player from Russia? Yeah, I guess Russia. Or Ukraine, I guess Russia. And this guy had heard about the virus on the radio, he got to work, and he actually had this email waiting on his inbox. And it's offering pictures of Anna Kournikova. And of course it's all fake. There's no images of Anna Kournikova anywhere, but it's a good trick to get people to click on the link. And he actually called me and said, yes, I know it's a virus. I heard about it on the radio. And yes, our product blocks it. But he would still like to see the images. Like, how could he say that? I was like, yes, what can I do? More viruses at the time, we are now in the early 2000s, bad trans, these are all email outbreaks. Nimda, which was probably one of the most advanced viruses we saw so far. This was found a week after the 9/11 attacks in the United States, and there was large speculation at the time that it could have been somehow related, but we could never actually prove anything on that. The reason why this was suspected was that it was so advanced, like so well written. But of course, probably was just conspiracy theories, which we keep seeing in this field as well. Class, bugbear, mymail, email spreading viruses, and some of these are very clever, like Swen. Because Swen was spreading itself in emails where it claimed that it's coming from Microsoft. And this actually looks pretty cool. This is 2003, so Microsoft updates didn't really exist at the time. You would actually go manually and download updates, like executable files from Microsoft.com yourself. There was no way to automate it for an end user. So you would send emails which claim to be coming from Microsoft, warns you about September cumulative patch, which patches problems with IE. Does this sound familiar to anybody? We're still doing this 7 years later. The funny part is that when it infects computers, it keeps sending these messages, but it always updates this. So for example, if you would run Swen today, it would actually send out emails warning you about the September 2010 update. So it will always be talking about the current updates, making it fairly credible. And this was actually a big problem at the time as well. And then we started to see web worms, internet worms spreading directly between computers. So no email involved, no user interaction involved. Outbreaks like Code Red, which would basically go around infecting websites. So web servers would get infected, and that's 24 hours, the first 24 hours in the life of Code Red in July 2001. Infecting, you can see the number going here, hundreds of thousands of web servers. These were basically Microsoft IIS servers which had a remote vulnerability in them. Somebody was actually, at the time, playing around with the idea of writing a fixer or a cleaner for this worm, which would actually use the same vulnerability to gain access to the infected boxes, remove the virus, remove IIS, remove Windows, replace it with Linux and Apache, and then restore the website. Right? This is doable because you had root on the box remotely, so basically you could do this. And you can. This was actually never happened, but the idea is pretty funny. You can imagine how confused the administrator would be. That what happened? Like, how come my website is so fast now? All right, then we had Slapper, which was a Linux worm, pretty similar to what we saw there. Slammer, Windows worm, and the thing that's similar in all of these is that you would get infected while you were sleeping. So there was no human interaction required at all. And the biggest of these was Blaster. And this is 2003, the year that changed how we think about worms. And this is the reason why in Windows world, personal firewalls became the norm. Before 2003, you install a Windows box, it has no firewall. If you wanted a firewall, you had to buy it separately or install it separately. Most people were relying in corporate environments, a big checkpoint box protecting everyone, but the actual desktops had no personal firewalls at all. No, this changed. Blaster, which would infect you remotely using vulnerability and RPC vulnerability, and SASTER using the LSASS vulnerability. you would get infected through your network connections, and you don't have to be at a computer for this to happen. You can be sleeping, and your machine still gets infected, and it spreads the infection further. And these spread very, very quickly. How come they spread so quickly? Well, it's not that hard to imagine. How many IP addresses do we have in IPv4 address space? Well, actually, it's fairly easy to calculate. Just multiply 255 by 255 by 255 by 255, so you get 42 billion IP addresses, which isn't a big number at all. In fact, you can easily, well, not easily, but you can scan them all. And this is actually exactly what Blaster and Sasser and Slammer did. They scanned every single public IP address in the world. So if you were online in 2003, your machine or your phone or whatever device you had online with a public IP address was scanned multiple times by both Blaster and Sasser and some of the other ones. So they would just blindly scan IP addresses. Whenever it would find, of course, most of the addresses they would scan would be in use or would be unreachable or something like that. So of course nothing happens. But it just keeps on scanning. And when it finds a live IP address, of course some of those IP addresses belong to computers it can't infect. So for example, Windows Worm finding an IP address belonging to a Mac, so it can't do anything. Or sometimes it finds a computer which is online, which is the right operating system, so it's a Windows box. But there's a firewall, so it can actually reach the RPC port or the LSASS port. So again, nothing happens. Or there's no firewall, but the machine has already been patched. That's a patch, right? So it can't reach it. But of course, because it will continue scanning endlessly, eventually it will find a computer which is online, which is the right kind of a computer, which has no firewall and which hasn't been patched. And it will be able to infect it right away, right then, right there, which means this machine will now start scanning. In fact, they are now both scanning the net. So it gets faster and faster, it grows exponentially. And this is the explanation how they could reach the whole net and scan every single IP address in the world multiple times. So what would Blaster look like when you get infected? Well, it would look like this. You would get an error message from Windows that the RPC process has a remote procedure call, service has terminated unexpectedly, Windows can't live without that service, so it reboots. All right? And your machine will shut down and reboot. And then a couple of minutes later, you see it again. And it will shut down and reboot. Very frustrating. You can't work. What do? Well, you ask someone, like, what's going on? What do I do? Ah, that's a worm. You have to get rid of the worm. All right, how do I get rid of the worm? Well, you have to patch the RPC vulnerability. All right, how do I patch it? Well, you go to Microsoft.com and you download the patch. Again, at the time, we had no Windows updates. You have to do it manually. So let's do this. Let's go to Microsoft.com. We'll find the right patch. Excellent. That's the patch we want to download. Let's click on the download button. Yes, we want to download it. Let's save it. Let's put it over there. And now we're downloading. Excellent. It's coming down at a great speed. And during the download, you would typically get the same prompt again, because you still weren't patched. And now you have two counters on your screen. One is the download counter, trying to download the patch. One is the shutdown timer, calculating seconds and how long you have to go before your machine reboots. And this game was being played by computers all over the world. And as you might guess, many of the cases ended with the end user losing the game. Machines rebooting just when you were at 90% download for the patch. Then you try to do it faster. Very, very frustrating. And this is the reason why Microsoft changed their attitude towards worms. This is why they released Windows XP Service Pack 2, which had firewall enabled by default. This is why they changed their this security model altogether. They stopped developing new code for 2 months, had all the developers go back to look at the old code. That's why they started implementing Windows updates. So they really had no other option. They had to do something, and they did. And some of these outbreaks at the time were pretty massive. This is packet loss statistics on the day of the slammer in the whole net. On a typical day in the net, you have packet loss somewhere in the 2 to 3% rate. Suddenly, when Slammer started spreading, global packet loss jumped to 20%, which is pretty neat. In fact, Slammer managed to reach many critical infrastructure places as well, including infecting nuclear power plants, infecting train systems, plane systems, 911 services, ATMs. Pretty spectacular, especially for a worm which even didn't try to do anything like that. It was just trying to spread. But it nicely shows what kind of things we had online, or had online at the time. And critical infrastructure is something to worry about. It was already something to worry about 7 years ago, and it's still something to worry about today. couple of screenshots I took at the time. This is Air Canada announcing that Blaster shut down. This is August 2003. Blaster shut down their flights. Here's a photo taken from the Air Canada checking desk. Can anybody spot what's the problem? Yes, it's the blue screen on the right side. This is a screenshot from CSX, which is the largest railroad operator in northeastern USA. And they have a press release out saying that they had an internal infection, which resulted in slowdown of major applications, including dispatching and signaling systems. As a result, all passenger and freight train traffic was halted immediately, including the morning commuter train service in the metropolitan Washington, D.C. area. Think about it. All the trains in the capital of the United States of America were stopped because of a computer work. Isn't that incredible? But this actually happened 7 years ago. This happened. And there were many other places which were hit by Blaster, Slammer, and Sasser. For example, we were fighting a large outbreak in these. These are forest tractors, which, yes, run Windows. We had these shut down in the middle of forests. They wouldn't boot. I mean, they wouldn't start. So they actually had, we were working in a case where they were basically taking nerds in other tractors in the middle of the forest to figure this out and clean up the machines so they could actually continue forestry operations because they were infected by blasters. And then this is a screenshot from a Swedish magazine at the time saying that there were 5,000 computers infected in 2 hospitals in Sweden, which is bad, but that's not the worst. The worst is that not only computers got infected, these become infected as well because their X-ray systems were running Windows and they got infected and they were rebooted. So there were actual cases of patients being transported in ambulance cars to other hospitals to be cared for because the X-ray systems were infected by a virus in a hospital. But then we have something big, because the same year, 2003, we found Fissure. Fissure isn't very famous, but it probably should be, because Fissure was the first virus that we could conclusively prove that this virus was written to make money. And that's only 7 years ago. And of course today, all the viruses, all the malware is written to make money. All of today's attacks are done by organized criminal gangs who want to make money with their attacks. But the first case actually wasn't that long ago, only 7 years ago. Fissure made money by sending spam. So basically took over the computers and used them as an SMTP proxy and sent lots of Viagra spam through the infected computers. Very basic stuff. Only 7 years ago. That's when it started. So basically that also meant that the origins of where viruses are coming from switched. Before 2003, viruses were coming mostly from developed Western nations. Western Europe, USA, Australia, Japan, and they were written by guys who just wanted to write them for fun. After 2003, today, most of the viruses are coming from Russia, China, and South America. Especially Brazil is a hotbed of activity for bank control. And of course, Russia, I don't just mean current Russia, I mean pretty much all of the ex-Soviet Union. So mainland Russia, Belarus, Ukraine, Kazakhstan. In Europe, Romania probably would be the biggest hotbed of activity right now. And the virus writers changed from guys who looked like these, including here in the upper right corner, checking how, who wrote the famous CIH, aka Chernobyl virus, which would actually, on the Chernobyl anniversary, overwrite your hard drive and overwrite your flash bytes, meaning that your whole machine would actually be inoperable. So these guys were the old enemy, and after 2003, the enemy looks pretty much like these. Professionals, organized gangs, the Ruskranians, that's Russian Ukrainians, and so on. So quite different. Today, the enemy makes millions with their attacks, which means they can afford to invest in their attacks. Moving on, we had Sovic, which was the biggest email outbreak so far in 2003, Wittyworm, which was actually infecting computers, Windows computers, through a vulnerability in a firewall. So there was a remote exploit in one particular firewall product, and it actually would get infected because you had a firewall. MyDoom, Bagel, Netsky, the first bots start appearing, and then we found Kabir. And Kabir is different because pretty much everything we've seen so far is DOS or Windows viruses. Kabir is a symbiont virus. Very first virus infecting mobile phones. This was 2004, so 6 years ago. And Kabir would actually infect your system through Bluetooth message. And one thing we noticed very clearly when Kabir came around is that when people would actually get infected by Bluetooth-based viruses, Kabir, Warrior, or any of the other early mobile phone viruses, there was a very clear tendency to blame the user. Like, why on earth did you accept the Bluetooth message? Why didn't you just deny? You don't have to accept Bluetooth messages. Why did you have Bluetooth on your phone to begin with? And this actually was unfair. It wasn't a user problem. And I can show this to you by this video. What we have here is a video we've shot in one of our RF labs. We have these shielded rooms where we can safely replicate mobile phone viruses so they don't escape. And here we have a Symbian phone which is receiving a Bluetooth transmission from an infected phone. You can see, well, the other phone over there is infected. It's beaming the Kabir virus to this phone right now. So you can imagine that this is your phone, right? It's in your pocket and you're in a bar having a beer. Then someone else walks in the room with an infected phone and gets within your Bluetooth range, and the virus starts beaming itself to your phone. The way it shows up on your phone is this. Your phone says, receive messages via Bluetooth from, and the name of the sending phone. But you wouldn't notice that because your phone wouldn't ring, it wouldn't vibrate, it would just ask questions. So your phone would be in your pocket, you would be drinking your beer. Then 10 minutes later, you remember you were supposed to call your wife, right? So you pick up the phone from your pocket and try to make a phone call, only to realize you can't because there's this message on your screen and you can't ignore the message. You have to answer the message. So what do you answer? Yes or no? Well, of course you're going to answer no. No, I don't want a Bluetooth message. But watch when we click no button. The virus sends itself again. It sends itself again. It sends itself again. It sends itself again. So okay, let's ignore the message. Let's just make the phone call. Let's just call the wife. But the numbers don't work. No? You try doing anything, it won't work. Let's go to the menu and disable Bluetooth. But the menu button doesn't work. So you can't ignore the message. That's the problem. When we spoke to people and asked, why did you say yes? Why did you accept the Bluetooth message? They would always answer back that no, it didn't work. I had to make a phone call. What else could I do? So what else could you do? What could you do in a situation like this? Well, you could walk away. Just walk out from the bar. Walk away from the Bluetooth range and the message disappears. Then you can make the call. Then you can disable Bluetooth. You can do whatever you want. But this isn't obvious to the end user. Like, I got this weird message on my screen, so I'm going outside. Like, it doesn't make any sense, right? So no wonder. It wasn't actually a user problem. It was a user interface problem. Why viruses like these were a problem around 6 years ago. And of course, this was changed. Today, for example, phones like these would know. You click no and it will remember it. It caches it for half an hour. So you actually don't have the same problem anymore. And as a result, we don't have Bluetooth viruses in it. They've gone away. Then we have different bots coming around. First, rootkits appeared, including the infamous Sony rootkit, which we found in 2005. Sony still doesn't like us for some reason. We found the rootkit from these music CDs shipped by Sony BMG, including music CDs from Switchboot, from Van Sant Brothers, and from Celine Dion. And I have friends who believe that if you listen to Celine Dion, you earn to be infected. So basically they had a copy protection system on these CDs. When you would use your Windows computer to listen to these music CDs, it would install a driver which would actually rootkit your system. And we did that to hide the DRM system, but it actually turned out that it would hide pretty much anything at all. And we started to find viruses which were using Sonic rootkit to hide themselves. And there was a very nice quote given by one of the executives from Sony. Let me play it to you.
Most people, I think, don't even know what a rootkit is, so why should they care about it?
Thomas Hesse is president of Sony BMG's global digital business.
I think was such an excellent quote. We actually made T-shirts out of it, so maybe that's one of the reasons why Sony doesn't like it. Then we started finding more larger outbreaks, including Stormworm, which I have a short video here as well. We actually shot this in our lab from one of our systems which tracks infections around the world. So all the dots you see on the map are just normal viruses. When we get closer and closer to midnight, so it's now 6 p.m., you can see the clock ticking away there in the corner. And around midnight, the outbreak starts, and you'll be able to tell pretty clearly. So it's 10 o'clock, random infections. This is not yet storm, and storm starts here. So that's what an outbreak looks like. Like millions and millions and millions of infected machines around the world. And you can see critical level of activity here, then it drops down around here. Yeah, back to normal. So it lasted around 7 hours. So that's what an outbreak, email outbreak looks like. That was storm. And then we found Memoirs, which was probably still is one of the most advanced malware we've ever seen. Memoirs was probably written by some sort of gang operating both in Russia and in Italy. First infections were spread as drive-by downloads from a website. She's called Monica Bellucci. This is from Matrix 2. She's an Italian actress, and her website was the first website we saw that was actually spreading infections of Memoirs. So if you would visit monicabellucci.it, it would actually run a short script to infect your system, drop Memoirs, which would be a Windows boot sector infector. So it would write itself to the MBR of your hard drive, which means the next time when you boot up Windows, the next time you boot up your computer, the first thing that runs from your hard drive is already the malware. So the malware boots up first, it boots up its own small kernel, which it calls MAOS, malware operating system, and then it's the malware that boots up Windows. And every time when Windows during boot jumps to your higher ring, Memoirs jumps to your higher ring. In the end, Windows is up and running, and Memoirs is already in memory. And not a single file on your hard drive has been modified. And this is very, very hard to do. We were really surprised these guys had the know-how and funding to do this. But my favorite part about Memoirs is what happens when this happens. If your machine blue screens while you're infected by Memoirs, the Memoirs gang is so serious about their Q&A that when this happens, Windows has now crashed, but Memoirs is still running. And now Memoirs will take a diagnostic dump of your crashed Windows box and send the dump over the internet back to the guys so they can figure out why your box crashed and improve Memoirs to make sure it won't happen again. Can you believe that? That's what it did. And then we enter the days of Partnerka. And these are the Russian affiliate networks that are one of the biggest headaches we have today. Affiliate networks where anybody can sign up through a website like this, to sign up as an affiliate to resell a product. And every time you sell the product, you get 50% of the money to be made out of it. Now what's the product you're selling? Well, the product is, for example, this. This is Data Doctor 2010, written by a Ukrainian company operating in Kyiv. And this is a file fixing tool. It fixes corrupted files. So, for example, if you have a digital camera and you run out of battery and one of the images, the JPEG files on your memory card get corrupted, you can't view it, this might fix it. It actually is a real product. It actually works. It actually fixes corrupted JPEGs and doc files and files like that. It's far from being the best product in the marketplace, but it's not fake either. It actually does things. The funny thing is that the company that made the software, they aren't selling and they aren't marketing their own product at all. All the sales and all the marketing are done through their affiliates. And all of their affiliates are online criminals. All of their affiliates are guys who have already created their own botnet and are now trying to find ways on how to monetize that botnet. How to turn those infected computers, tens of thousands or hundreds of thousands of infected computers, into cash. And the way they convert them into cash is that they force the owners of those computers to buy this product. Now, how do you force someone to buy a file fixing tool? Well, you do it by corrupting their files. So from the user's point of view, what the user sees, he's on his computer, he's working normally, and then suddenly in the middle of everything else, he gets this error message. That's a bit similar to what you saw with Blaster, but it's a bit different as well. If you look at what it says unrecognized disk driver command. And unlike the message from Blaster, this message is not coming from Windows. Yes, it looks like a Windows message. It is not a Windows message. This message is displayed by the bot. So your machine is already infected and the bot shows you this message and then shuts down your Windows. Reboot Windows into Windows safe mode and shows another error message, which says, Windows has recovered from serious error. Some files can be corrupted. That sounds pretty bad. So of course you would go and check your files. And guess what? Every single doc file, every single Excel file, every single PDF, every single text file, you can't open them. Your most valuable stuff on your computer, you've just lost it. They're all corrupted. Actually, they're not corrupted. They are encrypted. The bot on your computer has just encrypted all your files. And if every time you try to open them, they fail. So of course, by now, the user is panicking. Oh my God, I've had a hard drive crash, I've lost all my files. And I can guarantee to you that every single user in this situation will be clicking on this repair file button right here, right? And as you might guess, what the repair file button does is that it will download and install Data Doctor 2010. And then when you click the file fixer button, it will scan your hard drive and it will find every single one of your corrupted documents. And when you click the fix it button, it will fix your files. Unfortunately, it will only fix one file because you're running an unregistered version. And if you want to fix the rest of your files, you have to buy the product, which costs you $91.45. 50% of which goes to the company that made the product, 50% goes to the botnet master who infected your computer in the first place and who corrupted your files in the first place. So it's basically taking your files and asking for a ransom. Except that's not what the user thinks. What the user sees and thinks is that, oh my God, I had a hard drive crash. Thank God Microsoft recommended this great tool which fixed all my files perfectly. I'm going to recommend this tool to all my friends. So users are happy to pay the ransom to get their files. And this is much harder for us to find because the company who made the product probably isn't breaking any laws. So they aren't infecting anybody, they're just fixing files. Yes, all of their resellers are criminals, but hey, things like that could happen. And we have open investigations. This is from Interpol's webpage. This is one of the guys who they're trying to find right now who have been running operations like this. This guy was running interactive marketing in Ukraine, which had revenues of $130 million by selling rogue file fixers and rogue antivirus programs. Then we had Configure. Last year, of course, one of the biggest cases in history. Great mystery. Nobody knows who's behind it. Nobody knows what's the motive. Nobody knows whether these guys are still planning on using their botnet, which still has close to 10 million infected computers online today. 10 million. Think about it. The Configure is interesting in many ways. One thing it does is that it blocks, it will not infect certain IP ranges, and it blocks all connections from those IP ranges to itself. And those IP ranges belong to different antivirus and security companies, including our IP range, which is interesting. Another interesting thing is how it spreads over USB sticks. Normal USB worms look like this. They create an autorun file at the root of your USB stick with commands like this. This is not Configure, this is just some random USB worm. Configure also creates an autorun file on USB sticks, but the Configure autorun file looks like this. And when we first saw it, we just assumed that there's a bug. There's a bug in the virus, which isn't rare at all. Obviously, this will not work. That's just random binary garbage. That's not an inf file at all. Inf files are ASCII files. But if you actually take a look at the file, which is random, changes every single time, around 30 to 40 kilobytes in size, if you just keep staring at it, if you just look at it, keep looking at it, you will eventually see that there are these snippets in the middle of all this binary junk. And it turns out that when you show an inf file like this to Windows, Windows can happily ignore all the binary junk and interpret and use this command. So it actually works. And what it actually does is that when you put in a USB stick, which is infected by Configure, you get the autoplay functionality to look like this. Watch carefully. There's two options here. The default option is open folder to view files, right here. But there's another one right here, open folder to view files. This is the real open folder to view files. This is the one created by Configure. If you choose this one, you get infected. And that's the default option. So no wonder people click on that. You just put in a USB stick and you hit enter, you're infected. Then in January this year, we saw Operation Aurora in the news. That was the case of Google announcing that they've been infiltrated with targeted attacks. And these targeted attacks are fairly nasty. We've been watching them for 5 years, and they are completely different from all these money-making attacks. Because here, the attacker isn't interested in making money. This is all about espionage. Corporate espionage and country-to-country espionage. Well, what it typically looks like, here's a video that shows what happens when you open up an email attachment sent to you. So you get an email from someone you know. Hi, here's the file I promised to send to you in our last meeting last Thursday. And you had a meeting last Thursday. There's a file called research report.pdf, and then we're going to open up that file, that PDF file with Adobe Reader. Now watch carefully. Adobe is starting. Here's Adobe Reader, and blank, it goes away. And it's still starting, and here's the file, everything looks great, except the file name. At the corner it says book.pdf, and the file we opened was called research report.pdf. So this is not the file we opened. And if you go and have a look at the task manager or process monitor, you'll actually see that there's an extra file called a.exe suddenly in the root of drive C, and it's already executing. So yes, the PDF file we opened had a vulnerability in there which exploited Adobe Reader, created two new files. One of them was the clean PDF file which showed just to fool the user. The other one is a backdoor which connects back to the spy, giving him full access to everything on the computer. And we've seen many of these. We had one case in UK with a huge billion-dollar-sized military contractor where the R&D director's personal laptop was infected by one of these for 18 months before anybody noticed. So for a year and a half, they were leaking information to an IP address in Taiwan. Nobody knows what exactly they was. And the files that are used in these attacks are very convincing. I have several examples here. These are all examples of files which have been used in these targeted attacks. What's common with them is that they look very credible. They look like real documents used in real company use. But they're all fake and they all contain backdoors. And we've seen this in different languages as well. I don't read Arabian, but I'm sure that would be credible as well. Then we saw this year 3D anti-terrorism. Why is this important? Well, it's important because here we have a phone virus which makes phone calls. We tried to investigate why people were reporting these weird phone calls from their Windows mobile phones. And we've realized that what's common with all the users who had the problem was they had all installed this game. The game is called 3D Anti-Terrorist, which is basically a Counter-Strike clone for Windows mobile devices. It looks like that. It's actually a fairly neat game. It's a commercial game written by a company in China called Hypponen. And this Chinese company, they've done nothing wrong. But a Russian hacker took this commercial Windows mobile game, hacked the game, removed the copy protection, posted the hacked version to several download sites for free. So people were downloading this game by the thousands because it's a good game and now it's free. But of course there's also a modification in the code. Specifically a small modification which makes the phone issue phone calls for 55 seconds. 8 calls for 55 seconds once a month. And when you check where do these numbers call and how much they cost you, when this happens it's going to cost you around €9. So you will pay for this in your phone. And this money goes to the body squad. Well, how does that work? How does he actually get the money? Where do these numbers go? Well, these numbers go to the South Pole. They go to Somalia. They go to the small island nation of South Togo. And these are what we call short-stopped numbers. The basic idea is that they are rogue phone operators which claim that they, for example, your phone call from USA to Somalia goes through, when in fact, in reality, it gets stopped short at some much cheaper location, yet they bill you the full amount of the bill. And that money is then transferred to the owner of the number. So these are basically creating premium rate numbers out of normal numbers, which means there's no anti-fraud mechanisms in place, nobody actually monitors these numbers. And surprisingly, there's a wide range of companies selling numbers like these. So for example, if you want to, you can go right now, today, and buy yourself a phone number from North Korea. And when anybody dials that number in North Korea, you get money out of it in real time. So we expect to see much more mobile phone malware doing exactly this. And I'm going to go over by 2 minutes because I just added new material about Stuxnet, which I'm sure many of you are aware of, and which I believe to be probably the most important malware we've seen in 10 years. Stuxnet was found in the summer. It was found because it used a zero-day vulnerability, the so-called LNK vulnerability. This one is spreading over USB sticks, infecting computers when you put the stick in. But there were many weird things about this. When it was investigated further, it was realized that no, it didn't just use a zero-day vulnerability. It had multiple 0 days. Not one, not two, but 4 different zero days in the same malware. And we've never seen that. We've never seen, ever, a malware which would use more than 1 zero day in the same code. Very unusual. It was also a rootkit, but it wasn't only a rootkit on the Windows computer it infected, it also installed a rootkit on the Siemens Simatic WinCC SCADA operational platform used in factories. And we've never seen a rootkit for any of these. In fact, we've never seen malware which tries to do anything at all to factory operational systems like this. And this case has been in use a lot because most of the infections are in Iran, which is weird. And I was doing some investigation and I found this posting where somebody early on during the infection is writing in, and he's actually in Iran himself. He's at a steel factory. We have this virus everywhere, on our WinCC servers, on our clients, and so on, and asking for help. So you can imagine how desperate this situation must be in factories which actually rely on these. And it's not only factories.